Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the various instruction set used in assembly language programming for 8051 microcontroller. In that video, we have also seen the assembler directives of assembly language programming. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the various electronic component interfacing with the 8051 microcontroller. In that, first of all, we are going to see the LED interfacing to 8051 microcontroller. We know that LED stands for the light emitting diode and it is a normal PN junction diode. When it gets forward biased, it emits light, hence it is named as the light emitting diode, and it has the two terminals, anode and cathode. I hope you all have the basic idea about the LED and its working. Now, let's start our today's topic, the LED interfacing to 8051 microcontroller. The light emitting diodes are the most commonly used components in many applications. LEDs can be directly interfaced to the ports of the microcontroller. LEDs have voltage drop of 1.7 volt and current of 10 milliampere to glow at full intensity. That means for the glowing at full intensity, LEDs have the voltage drop of 1.7 volt and current of 10 milliampere. The LEDs are connected with the microcontroller with the fixed value of the resistor. This is the very important statement here that LEDs are not directly connected with the 8051 microcontroller's pin. It should be connected with the pin of microcontroller through a fixed value of resistor. Okay. The value of the resistor can be calculated by using the following formula. R is equal to V minus 1.7 upon 10 milliampere. That means this formula is derived from the Ohm's law, and Ohm's law we know that V is equal to IR. Okay, from this formula we can calculate the value of R as V upon I, that means voltage upon current. We know that in 8051 microcontroller circuitry we use the voltage source of 5 volt DC, and to glow the LED at full intensity we require the voltage 1.7 volt. Hence here the potential difference is here, hence here is 5 minus 1.7 volt upon I is 10 milliampere. Okay, that means 5 minus 1.7 is equal to 3.3 volt upon 10 milliampere, means 10 into 10 raised to minus 3. Okay, after simplification of this we get the value of the resistor as 330 ohm. That means for interfacing the LED to the 8051 microcontroller we require 330 ohm resistor. This value is changed depending upon the voltage drop across the LED, and it is different for the different types of LED. I hope you all understand this calculation and how to calculate the value of the resistor. Okay, now let's move to the our next point, the LED interfacing type. We can interface the LED to the microcontroller by using these two techniques, LED interface 1 and LED interface 2. Let's see LED interface 1. In this interfacing, the anode is connected with the pin of the microcontroller and the cathode is connected to the ground through a resistor. Okay, to glow this LED, we have to provide one to this pin or one to the anode. Okay, because it is connected with the ground at the other end. Hence, to glow this LED, we have to provide it one, that means 5 volt to the anode of this LED. This is the one type of interface, and let's see here the anode is connected with the input voltage 5 volt through a resistor, and the cathode is connected to this port pin. Here the 5 volt is given, but to glow this LED we have to give here 0, that means ground, to this pin. Okay, I hope you all understand. Let's see once again. To glow LED in LED interface 1, we have to provide 1 or 5 volt to anode. In LED interface 2nd, to glow this LED we have to provide 0 or ground to the cathode. Okay, I hope you all understand how LED interfaced with any pin of 8051 microcontroller. Okay, now this is the general diagram of LED interfacing. Let's see the description about this diagram. In this diagram, the pin number 9 is connected with the reset circuit. This is the reset circuit. When we reset the microcontroller, it comes at its initial value. Okay, we all know that the pin number 19 and pin number 18 are connected with the external quartz crystal. Okay, it generates a clock circuitry, and these pins are grounded through these two capacitors, each having value 22 picofarad, or in some cases the value of the capacitor is 33 picofarad. Okay, I hope you all understand. And here the port P3 is shown, and each pin of port P3 the LED is connected. Okay, that means at the pin of P3.7 the LED is connected, that means the anode is connected to the port pin, and cathode is connected to the ground through a fixed value of resistor, and the value of the resistor is 330 ohm. Okay, we have seen this type of interfacing in these two diagrams. In this diagram, if we want to glow the LED 1, then we have to provide a 1 or 5 volt to P3.7 pin. Okay, if we want to glow LED 8, then we have to provide 1 or 5 volt to P3.0 pin. Okay, I hope you all understand how to glow the LED. Okay, now let's see our next point. This is the general description of this diagram. This description says that the circuits mainly contains 8051 microcontroller. There are 4 ports, P0, P1, P2 and P3. This is the very important statement here, that port P0 requires external pull-up resistors for its operation, and the other ports, port P1, P2, P3, have internal pull-up resistors, hence they do not need external pull-up resistors for its operation. Hence, for that purpose, here in this diagram, the LEDs are connected with the port P3. P3 has internal pull-up resistors, hence there is no external pull-up resistors are connected with the pins of the port. Okay, if we use port P0 here, then we have to connect these types of pull-up resistors to the pins of the port P0. I hope you all understand, and this point is already discussed in the previous lectures. Okay, the controller is connected with the external crystal oscillator to pin 19 and pin number 18. Crystal pins are connected to the ground through the capacitor 33 picofarad or 22 picofarad. Anode of LED is connected to the microcontroller pin, and cathode is connected through a resistor to ground. So when port pin is high, the LED is on. The port pin is high means when the port pin is 1, that means when the plus 5 volt supply is given to the LED, then it is on, and the port pin is low, that means when port pin is 0 or grounded, then the LED is turned off. Okay, now let's see one example here. Write an assembly language program, and for blinking of LED which is connected to the port P1.1 pin, and also draw its interfacing diagram. Okay, here is the interfacing diagram of the LED with the microcontroller is shown here. In that this section, we know that this is the clock circuitry. That means the pin number 18 and 19 is connected with the external crystal oscillator, and it is grounded through the capacitors. This is the reset circuitry, and it is connected with the pin number 9, and we want to blink the LED which is connected at the P1.1 pin, and this is used to obtain the status of the pin. Okay, now let's see the assembly language programming. This is the assembly language program used to blink the LED at the P1.0 pin. Here the one correction is here that this pin is P2.0. Okay, this pin is P2.0, and here is the P2.0 pin. Hence, for that purpose, there is no external pull-up resistor is connected. Make this correction. Here, this pin is P3.0. Okay, I hope you all understand the fault. Now, this is the program, assembly language program, to blink the LED which is connected at the P2.0 pin of 8051 microcontroller. Let's see the first line, ORG00H. That means it sets the origin at 00H. Then the next instruction is CLR P3.0. That means clear P3.0. This instruction means it clears the P3.0 bit. After execution of this instruction, the P3.0 is now become 0. Similarly, there is next instruction is CLR P2.0. That means clear P2.0. After execution of this instruction, the P2.0 pin has the 0 value. Okay. The next instruction is again JB P3.0, on. That means if P3.0 bit is set, that is P3.0 pin is 1, then jump to the relative address on. But here P3.0 pin is 0, hence there is, after this instruction, there is no jump to on because the P3.0 pin is 0, hence this condition is unsatisfied. Then the next instruction is executed. The next instruction is set bit P2.0. Now in this instruction the P2.0 pin is set. Okay, here now the value of P2.0 is 1. Okay, P2.0 pin is 1. That means our LED connected with the microcontroller is now turned on. Okay, I hope you all understand. The next instruction is a call delay. That means absolute call to the delay subroutine. After the execution of this instruction, the main program is shifted or jumped to the delay subroutine. Then this subroutine is executed first. This subroutine contains the delay in which move the delay subroutine shows the delay move R0 hash 05H. That means the 05H hexadecimal value is loaded into the R0 register. Go move R1 comma hash 0FFH. That means the 0FF value is loaded into the R1 register. Here DJNZ R1 comma here. This instruction means decrement and jump if R1 is not equal to 0 to here. That means decrement jump to here up to which R1 is not equal to 0. When R1 equal to 0, then jump to or proceed with the next instruction DJNZ R0 comma go. This instruction also similar to this instruction. That means decrement and jump to go up to R0 is not equal to 0. When R0 equal to 0, then go to the next instruction. The next instruction is return. When this return instruction is executed, then continue with the main program, and the main program is at this point CLR P2.0. At this instruction, the P2.0 is now 1, and after call delay subroutine, the P2.0 pin is now cleared. That means P2.0 pin is now 0. That means when the P2.0 pin is 1, that means plus 5 volt is provided to the LED and the LED is on. And when the CLR P2.0 pin, this instruction is executed, P2.0 is now 0. 0 means this pin is connected with the 0 volt and the LED is in off state. Okay, I hope you all understand the program. Now, after clear P2.0, then the next instruction is a call delay. That means again it jumps to the delay subroutine, and after execution of this delay, the next instruction is SJMP again. That means short jump to again. This process is continuous. Okay, I hope you all understand the program. Now let's see the next point, the 7 segment display interfacing to 8051 microcontroller. We all familiar with this 7 segment display. The 7 segment display can display digits from 0 to 9. The 7 segment display consists of 7 LED. That means this each segment is a LED. There are total 7 segments. That means there are total 7 LEDs in this type of display. Okay, different characters can be displayed by selectively glowing the required LED segments. That means if we want to glow one, then we have to glow these two LEDs. For example, let's see here, to want to glow one, we have to glow these two LEDs. Okay, the other numbers can be glowed by using the different, by glowing the different segments which is shown in this animation. Okay, here 9 is displayed, 8, 7, 6, 5, 4, 3, 2, 1 and 0. I hope you all understand the 7 segment display. The 7 segment displays are mainly of two types, common anode and common cathode. Let's see once again, the LED have, this is the LED. Okay, these have two terminals, anode and cathode. We know that in 7 segment display there are total 7 LEDs. This is the first LED, second, third, up to there are total 7 LEDs. Okay, these LEDs emits light. Okay, these LEDs have the terminals anode and cathode. Okay, similarly anode and cathode. If we want to see the common anode type display, that means the anode of all the LEDs are common and is given to the plus 5 volt, and the cathodes are connected to the ground through a resistor. Okay, I hope you all understand the construction of common anode type display. Okay, to glow this LED, for example, let's see, if we want to glow this LED, to glow this LED, the plus 5 volt is already given to this. To glow this LED, we have to connect this pin to the ground, or we have to provide 0 to this pin. Okay, I hope you all understand. This LED is activated or glow by providing 0, hence it is known as the active low type of display. Okay, similarly we can see the common cathode type display. Let's see once again this diagram. this is first LED, second LED, and consider this is the seventh LED. Okay, this terminal is anode, this terminal is cathode, this terminal is anode, this terminal is cathode. Hence, we have seen here, or we are going to see the common cathode type LED or common cathode type 7 segment display. Hence, cathodes of the LED are connected together and grounded. Okay, that means the cathodes are all connected together and grounded. Hence, to glow this LED, we have to provide plus 5 volt or 1 to this LED, then it is on. Okay, I hope you all understand. Let's see once again. If we want to on this LED, then we have to provide it plus 5 volt, because ground is already provided. To on it, we have to connect it 5 volt through a resistor, or we have to provide it 1. Okay, I hope you all understand. Now let's see the diagram once again. Common cathode means the cathodes of all the LEDs are connected together and grounded. To on it, we have to provide it 1. Okay, we have, if we provide 1 to the A, the this LED is on now. If 0 is placed at the D pin, then this LED is in off state. Remember that in common cathode display, if we want to on a particular LED, then we have to provide it 1 or plus 5 volt. Similarly, in common anode, the anodes of the all LED are connected together and connected with the VCC, that means plus 5 volt. If we want to glow or on a particular LED, then we have to provide it 0 or ground. That means if we want to glow the LED A, then we have to connect it to the 0 or to the ground. For example, let's see, if we want to show 1 on the display of the common cathode type, that means if we want to glow 1 on the display of common cathode type, then only segment B and C should be on. Okay, other segments A, F, G, E, D should be off. To on means the B LED and the C LED should be on. We are going to see the common cathode. The cathode means the cathodes are grounded. Hence, only the segments B and C should have the value 1, while the other segments should have the value 0 to remain in off state. Okay, and if we want to glow or want to show 1 on this type common anode, then segment B and segment C should be on. Hence, segment B should be connected with the 0, segment C should be connected with the 0, and all the other segment connected with the 1 to remain off. Okay, I hope you all now better understand the concept of common cathode and common anode display. Here is the lookup table or the truth table for the glowing of the character is shown. First is common cathode lookup table. If we want to show 0 on common cathode, then segment H and segment G should be 0. Okay, segment H means this DP pin. Okay, that means if we want to glow 0, then this LED should be off. For that purpose, this LED is connected to 0 and H is connected to 0. If we want to display 1, then B and C should be 1. This is illustrated in previous. Similarly, for common anode lookup table, if we want to display 0, that means this segment is, we want this segment G is off. To of this G, we have to provide it 1 while other segments are 1. Other segments are 0. I hope you all understand the lookup table. Depending upon the position of these segments to 1 or 0, there are to display 0 we have to provide it hex value 3, display 1 we have to provide it hex value 06, to display 2 we have to provide it hex value 5b, that means this is 0101 is 5 and 1011 is b. I hope you all understand this concept. Now, similarly, in this lookup table, if we want to display digit 0, then its value is hex value is 03H. Okay, this is the interfacing diagram of 7 segment display with the microcontroller. We already know about this circuit and this circuit. The 7 segments are connected with the port directly through a resistors. Okay. Now let's see the program of 7 segment display interfacing with the microcontroller. ORG00 means origin sets at 00H. The next instruction is start move A comma hash 00001001 B. Here the B is written to show this value is binary and this binary value is directly loaded into the accumulator. The next instruction is move B comma A, that means A, the value of A is loaded into the register B. The next instruction is move R0 comma hash 0AH, that means the value of the value 0A is now loaded into the R0 register. The next instruction is label move A comma B, that means the content of B is now loaded into the accumulator register. INCA means increment accumulator move B comma A, that means A loaded into B. Next instruction is move C A comma at the rate A plus PC, that means this instruction adds the byte in the accumulator to the program counter address. The next instruction is move P1 comma A, that means the contents of the accumulator is now loaded into the port 1. Okay, because port 1 is connected with the 7 segment display. The next instruction is a call delay. After the execution of this instruction, the delay subroutine is called, and after completion of the delay subroutine, the main program is executed. The next instruction is decrement R0. Okay, the next instruction is move A comma R0, that means whatever the value of R0 has is now loaded into the accumulator. After the execution of this instruction, the next instruction is JZ starts, that means it checks the accumulator for the 0 and jumps to the start subroutine. Okay, the next instruction is SJMP label. SJMP stands for short jump and label is the title of the instruction. After the execution of this instruction, the execution of this loop is continuous. There is define byte 3FH means digit pattern for 0. Define byte 06 means digit pattern for 1. That means after this instruction, first of all, it shows 0. After this instruction SJMP label, it goes to the label again and the next character 06H, that means the next character 1 is shown on the display. Similarly, after each loop, the character 2 or the digit 2, 3, 4, 5, 6, 7, 8, 9 is shown on the 7 segment display. This is the delay subroutine in which the values are loaded into the register to generate a specific time delay. Okay, I hope you all understand the LED interfacing and the 7 segment display interfacing with the 8051 microcontroller. Thank you.